Alright, so this is 3.3 trig functions and general angles. We're going to be looking at the unit circle as well. We're going to use the unit circle a lot in this section and the sections after this. But the homeworks there are 12, 18, 19, 21, 24, 25, 28, 29, and 32. There's a little star by 32. It's optional, but it would be really good for you to try that problem. Hint, hint. There we go. So 13.3. So I can find values of trig functions for general angles and then find the value of trig functions by using reference angles. One quick thing, and here is our unit circle, right? It talks about what degree goes with cosine, sine, so cosine's there. So cosine 30 is the square root of 3 over 2. Sine 30 is just a half. That's how you kind of would use this. But now our first step, so evaluate trig functions given a point. So we're given the point 6 comma negative 2. So I'm just going to draw out where that is. So there's our little graph. So 3, 4, 5, 6, 1, 2. So our point's down there. We know that this is length of negative 2. This is the length of 6. And we need to first find what is the hypotenuse there, what is this radius. So to do that, again, Pythagorean theorem, so we had a squared plus b squared equals c squared. So we have 6 squared plus negative 2 squared equals c squared. So we have 36 plus 4 equals c squared. So we have 40 equals c squared. So c equals the square root of 40. Alright, so we have that. We know that the hypotenuse is square root of 40. And now we have to find sine theta. And theta is this angle right here. So that's theta. This one right there. Cosine theta. Tan theta. Cosecant theta, secant theta, and then cotangent theta. Alright, so sine theta, so if we're looking at this angle, we know sine is so it's opposite over hypotenuse. So we have negative 2 over the square root of 40. Now I can't leave that square root of 40 on the bottom, so I have to multiply by the square root of 40 on both the top and the bottom. So now I have 40 on the bottom over negative 2 square root of 40. And after you simplify the rest of this down, you should get negative the square root of 10 over 10. Alright, if you have questions on how we break that down, let me know. But that is sine theta. Cosine theta now, we're going to put tangent. We'll put tangent over here. Give cosine theta a little bit more room. But cosine theta now is just the adjacent over hypotenuse. So this is the 6 over the square root of 40. And again, when you simplify that, you should get 3 times the square root of 10 over 10. Alright. And then tangent is just the opposite over the adjacent. So that's negative 2 over 6 equals negative 1 over 3. Now again, if you're not really wondering how we simplify all this, let me know. I guess I can show you cosine up here real fast. So we have cosine theta and equals 6 to the square root of 40, so we multiply the square root of 40 on both sides, on top and the bottom. So we have 6 times the square root of 40 over 40. Alright. Now with the square root of 40, we can break down the square root of 40 to get a perfect square, which is 4 and 10. So this turns into 2. So then I have 6 times 2 times the square root of 10 on the top over 40. And then, do that right? Yeah. If I cancel out the 2 here, 2 there, now I'm left with 20, and I cancel out the 2 out of here. I now have 3 times the square root of 10 over 10. Alright, so that's how we got that answer. And if you are wondering how we're going to have to do that. Okay. Cosecant now is just flipped, so now this is negative 10 over the square root of 10. So we have to multiply the square root of 10 because we have to simplify it. This gets us 100 over negative 10 times the square root of 10. Upside down 100, just 10. There we go, which equals negative the square root of 10. Alright, so that's the cosecant. The secant, this time will be 10 over 3 times the square root of 10. Right, you just flip whatever the cosine is, which this will turn out to be the square root of 10 over 3 after you simplify. And then cotangent, you flip what the tangent was, so that's just negative 3. Alright. Again, if you have questions on how I'm getting these, let me know. We'll try it out first. Okay, so that's kind of what you have to do with that. Not technically really that difficult, it's just a lot of little technical work. Flip the page then. And we gotta talk about sketching each angle and then using its reference angle. Now, you can actually just use the unit circle. So we have 210. So there's that. So my angle here is 180, and then roughly it's like there. Alright. So this is my angle, and then my actual reference angle would be this angle right here if I wanted to have a, if I actually want to say what is the reference angle, just like that. So this is the actual angle, and the reference angle is this one right here. Alright. So this is 210 degrees. Alright. Negative 110. So for this one, right, if we have a negative, we're going down right off the bat. So it's going to be roughly about here. Okay. And our reference angle this time, again, is right here. That is our reference angle. Okay. And then this last part, 2/3 pi. Right, right here is a full pi. So you're roughly about there. And then the reference angle is right here. Okay, so this is 2/3 pi. This is negative 110 degrees, and this is 210 degrees. Okay, so if it just says sketch each angle, you can do that. No worries there. This just kind of talks about some stuff with reference angles and then trig values for special angles. But here, this is where we're going to use the unit circle. Alright, we have cosine 240. Now on the back of your packet, you have your own unit circle there. So cosine 240. Now, we know that cosine is going to be the first part of the ordered pair. 240 is here. So the first ordered pair, negative a half. Alright, so cosine 240 equals negative a half. And then, so now we have cosecant 5 pi over 6. This is where we have to figure out what is 5 pi over 6. You could do a couple things. You can first convert this to a degree. That's one option. You could use the reference angle if you wanted to. Another option. But if you know that pi over 6 is just 30 degrees, then, alright, so pi over 6 is just 30 degrees. So 5 of them would be 1, 2, 3, 4, 5. So it's 150, and we're looking for cosecant. But I know that cosine, so I'm just going to kind of jot down some little work here, but cosine is negative square root of 3 over 2, and sine is a half. Alright, now we have to decide, alright, what is cosecant? And we know that cosecant equals 1 over sine, right? So that's what cosecant means. So if the sine is a half, and cosecant is 1 over sine. So we have 1 over a half, which is equal to 2. Right, 1 divided by 0.5 is 2. All you have to do is flip this fraction and you'll get the right answer. So the cosecant of 5 pi over 6 is just 2. Alright, so then we're looking at the homework. Here it is. This is kind of like that first part I talked about. Here's just sketching the angle. Try to find the reference angle, and then we need to find the exact values using the unit circle. Now, again, you can use this. You could rewrite this a little bit, and you could put this right here is pi over 6. This is pi over a third, right? This is pi over 4. And you could write out what are each of these parts. I'm okay with that. Here's half a pi. Here's a full pi. Right? And you could work that around, and we'll probably have you do that sometime in class as well. Alright, so there's kind of your homework for 13.3.